Hello students, this is Mrs. Crumpton. Today we're going to be studying section 8.3, multiplying polynomials from your Glencoe Algebra 1 book. The pages for this section is pages 480 through 485. Your learning target: I can multiply binomials using various methods. Vocabulary: full method. Now if you're from the South, like most of us are, we say full. If you are from north of the Mason-Dixon line, they like to say it FOIL. Okay, so anyway, back to our definitions. Full method, shortcut version of the distributive property, and I'm going to show you a couple of different versions other than the full method. And quadratic expressions are expressions in one variable with a degree of 2. Okay, so let's start out with an example. Now I'm pulling this example directly from your textbook. Normally I don't do that, I give you additional examples, but I'm going to show you the full method with this particular problem. Now full stands for, the F stands for first, the O stands for outside, the I stands for inside, and the L stands for last. Okay, so now let's look at how this is going to apply with this particular problem. When I'm multiplying binomials, look at this closely. I've got two terms here, two terms here. This is a binomial term, so we're going to do the full method on this. The F stands for first. Now the first terms is the first term in each of the binomials. So I've got my F, my first terms is 2 times 2x. I'm sorry, 2x times 2. And that would, I cannot get this right apparently, 2x times x. 2x times x would be 2x squared. Then we've got O, your outside. Now I want you to think about when we were doing the distributive property previously, and we said, looking at this like we're hugging everybody in the house. This was the front door. This is the back door. So the outside are going to be the two terms that are getting ready to go out the door. So my outside is 2x times 5. That would be 10x. My inside are the two terms here that are in the middle of the problem, that are by the opposite facing parentheses. So that would be 3 times x, that's 3x. And then your last terms are going to be the last two terms in the binomials. 3 times 5. And that is 15. Now remember that we are going to need to combine our like terms when we have like terms. Our answer for this problem, 2x squared plus 13x plus 15. Now there's some other ways to do this problem too. Take just a minute and look at this and make sure that you understand the full method. And if you don't, be sure you are prepared to ask me questions about it tomorrow. Take a minute, look this over, make sure you understand it, give you another few seconds, and then I'm going to erase this work and I'm going to show you another method. The next method that I'm going to show you, this is not my favorite method, but it works for some students who don't understand full, and it's called using a Punnett square. Now, if you have ever seen one of these in science and you like doing these in science, a lot of times teachers will use this to teach blood types, how to figure out blood types. I call it window pane too. So what I'm going to do is I'm going to take this first binomial and I'm going to write it down the side. 2x plus 3. I'm going to take the second binomial and I'm going to write it across the top. X plus 5. And all you do here is still the same thing that we just did. We're multiplying. what goes in this box would be these two terms multiplied together. 2x times x, and that is 2x squared. 2x times 5 would be 10x. Then I would come to this box and I'm multiplying these two terms. 3 times x, that is 3x, and then 3 times 5 is 15. Then, if you've done everything correctly, you're going to have like terms across the diagonal right here. 3 plus 10, or 3x plus 10x, is 13x. Then I take and put everything back together. And my answer, 2x squared plus 13x plus 15. Again, that's just another method to do the same problem that we previously worked. Take a look at this. If you understand this a little bit better than the FOIL method, then you are welcome to use this instead of FOIL. Like I said, this is not my favorite way to do problems, but if it clicks with you and you understand this, then I'm good with you using this method. I've got one other method that I want to show you, and it's kind of a distributive property method. I'm going to erase now. I think you've had enough time to examine that one a little more closely. And with the distributive property, I'm going to start with this 2x. And I'm going to show distributing that 2x to the x plus 5. Then I will add 3 times the x plus 5. So this, again, just another method of working this same problem. Distributive property, hugging everybody in the house. I'd have 2x squared plus 10x. Then I'll have plus 3x plus 15. 2x squared plus 13x plus 15. Here you go, 3 different ways to work this same problem. Again, it does not matter to me which way you do this. I like the FOIL method better. This method's okay for me too, and I believe when you get to high school, it may benefit you to know this method a little bit, be familiar with this method. Try each one, see which one you like. There are some more problems on pages 480 and 481. Try those problems, play with all the methods, and see which one you like the best. There is one more example on page 480, and it is the binomial x minus 2, that quantity, times 3x plus 4. Let me write that one down for you. Let's see, x minus 2 times the quantity 3x plus 4. Okay, try that one. Now the answer is in your book for that one. There are some guided practice problems at the top of page 481. Those problems are 3m plus 4 times the quantity m plus 5. And the last problem that you could try, your guided practice, would be 5y minus 2 times the quantity y plus 8. Give those 3 problems a try. Use all 3 methods. Decide which one you like, bring it back to class, and then we'll discuss it. Next, we're going to talk about quadratic expressions. Alright students, let's look at a real-world problem here. This time we're going to be looking at a patio in the shape of a triangle shown to the right of this word problem is being built in a backyard. The dimensions given are in the measure of feet. The area A of the triangle is 1/2 the height times the base, B. Write an expression for the area of the patio. Well, in order to do this, we've got to translate this sentence. The area A of a triangle is. Okay, now think about this word right here. The area is. What symbol do I use here? Yes, some of you said equal sign, or at least you thought it might. ESP's working. The area A of the triangle is 1/2 fraction, 1/2 the height h times the base b. Now, if you remember the area of a triangle formula, then you probably didn't have very much problem setting that up. So my formula, area equals 1/2 the height times the base. Okay, now let's look at our diagram here of our patio. Our height is this little dotted end line right here. So my area is 1/2 times the height, which is 7x minus 7, times the base. Here's your base. 6x plus 4. Okay, now guess what? You get to use the method of your choice, whether it be the distributive property, the FOIL, or the Punnett square, and you're going to multiply this together. I'm going to use the FOIL method, and by the way, I didn't show you this a while ago, but if you do the FOIL method correctly, it looks kind of like a cartoon face. Now, if you've ever watched Peanuts, to me that kind of looks like Pigpen from Peanuts. Those of you who haven't watched it, you need to Google and see what Pigpen looks like, because it looks like that. Now, let's go back to what we were saying. First, outside, inside, last. Your FOIL method, first, outside, inside, last. Okay, so let's take our information here from the problem. We're trying to find the area of this patio. The area equals 1/2 the height, x minus 7, the base, 6x plus 4. Okay, now let's FOIL this. First times first would be x times 6x, that would be 6x squared. Outside, x times 4, 4x. Inside, negative 7 times 6, that would be negative 42x. Last, negative 7 times 4 would be negative 28. Now, I'm not quite done. I can't lose that 1/2. And I've also got to combine some like terms, which are right here. (6x squared minus 38x minus 28. Still not done, because now my formula tells me that I'm supposed to take half of each of these coefficients. So half of 6 is 3x squared. Half of 38 would be 19x. And half of 28 would be 14. Make sure you get your signs right in front of these coefficients. Now, also, look back over here to your problem, and see that our dimensions are given in feet. So this answer, the area of this patio, would be in feet squared. The reason it's in feet squared is because this unit of measure, the height is in feet, the base is in feet, so feet times feet would be feet squared. Okay, think on that one. Look it over real good for just a minute, and then I've got maybe 1 or 2 more examples for you. Alright students, this time we are going to be multiplying a binomial by a trinomial. Now to me, either the Punnett square method or the distributive property method is going to work for you on this. FOIL method is not going to work. So what I'm going to do is use the distributive property method on this one. Okay, I'm going to start out with 3. Ooh, no, not 3, 3x. 3x times the quantity, these should be x's, sorry, times x squared minus 12x plus 1 plus 4 times the quantity x squared minus 12x plus 1. Okay, now let's use our distributive property. Remember those rules. Also remember your exponent rules. So 3x times x squared, 3x to the third power. 3 times minus or negative 12 would be 36. X to the second power. 3 times 1, 3x times 1 would be plus 3x. Let's move on across. Let's get this part knocked out. 4 times x squared plus 4x squared. 4 times minus or negative 12x would be negative 48x. 4 times 1, you should know that one. 4 times 1 is 4. Now we've got to look for our like terms. And remember we talked about descending order of the polynomial or standard form of the polynomial? Let's start out doing that, okay? Take a look at the exponents on the variables. Which term has the largest exponent? That one. 3x to the third power. Now I'm going to take a different color marker, and as we go, I'm going to mark these out when I use them so I don't try to use them a second time. Okay, so I've used that one. Now I'm looking for x to the second power. Here is an x to the second power, and here is an x to the second power. So let's combine these terms since they are like terms. Like terms meaning that the... All right, students, we had a little bit of technical difficulties with the iPad, and we had to stop taping for just a minute. So you don't get too mixed up with the explanation. I'm just going to start back at this point. We had said 3x to the third power, and we were combining like terms here. So that would be negative 32x to the second power. We have another pair of like terms here. Subtracting those, different signs subtract. So we have negative 45x plus 4. Okay, take a look at that. See if you were able to follow me. If not, be sure you bring questions about this problem to class so I can take care of that for you. Now I've got one more example. Let me grab my book real quick just to make sure that I have copied the problem correctly, because y'all know I'm notorious for miscopying a problem on the board. Yes, again, I'm going to use this same distributive property method to multiply the trinomials together. I'm going to start out with this 2y to the second power, multiply it by this trinomial, y squared plus 3y minus 1, plus 7y times this trinomial again, y squared plus 3y minus 1, plus 9 times that same trinomial, y squared plus 3y minus 1. Alright, let's go over here and clean it up, and we'll call it a day on this video. I'll give you some formative assessment problems and a heads up assignment. So we've got 2y to the fourth plus 6y to the third minus 2y squared. Digest that. Make sure you understand how I got that. Plus 7y to the third plus 21. That's not 21, was it? 21y squared minus 7y. I am running out of room. Plus 9y squared plus 27y minus 9. Now we're going to have a lot of work to do to combine like terms. I'm going to come back all the way to the beginning. Do I have another 2y to the fourth power? Nope, I don't. So that one's going to go right here. And I'm going to mark it off because I'm done with that part. Or I'm done with that term. Okay. Now I'm looking for y to the third.
got 6y to the third. Here is another y to the third, plus 7y to the third. That's it. Combine those two like terms, and I have 13y to the third. Then I'm looking for y to the second terms. There's a y to the second. There's another y to the second. And another y to the second. So this is a minus sign here. Negative 2y to the second plus 21. That would be 19y to the second plus 9y to the second would be 28y to the second. Next is just y all by its little lonesome. I got one here, got one here. Negative 7y plus 27y would be plus 20y. And don't leave out a long constant like this, negative 1. That was a doozy. Now, let's talk about our formative assessment. These problems are going to come from page 483. And you're going to do problems 1, 3, 7, and we are going to try numbers 9 and 11. 5 problems for you for formative assessment. Your heads up is going to come from that same page 483, numbers 13 through 33 odd. Thanks so much.